Hello everyone, my name is Pradeep Kumar K and I am a faculty in the Department of Electrical Engineering at IIT Kanpur. This course is Electromagnetic Theory, one of the core courses taken by students in Electrical Engineering, Electronics and Communication Engineering and Telecommunication Engineering, typically in your third or second year. If you complete this course successfully, you will be able to do much well in the higher level courses such as microwave engineering, radars, antenna and optical fiber and optical communications. Now there is no exaggeration when I say that we live in an electromagnetic age. Right from an inverter or right from the power generation system to the high-end, high-speed digital computers or computing device or a smartphone, you will see the principles of electromagnetics being applied everywhere. Okay. Electromagnetics is the study of how charge distributions and currents generate various fields and how these fields themselves interact and how we are going to harness this electromagnetic energy in generation, propagation and radiation. Okay. So, this course is a kind of core curriculum for all these engineering students, and the course starts with static electric field, progresses to static magnetic field, talks about electromagnetic induction and finally culminates in Maxwell's equations, which is a historic triumph for physics and forms the cornerstone for electromagnetic engineering applications. We will then discuss various aspects of electromagnetic energy related to propagation and radiation. We will discuss transmission lines, which are extremely important if you want to design high speed digital or analog systems. We will discuss microwave engineering concepts such as waveguides. We will also discuss optical fibers, which are the way in which data is carried today. So, if you understand optical fibers thoroughly after understanding electromagnetics, then you can perform very well in that particular subject. And finally, we will touch briefly upon radiation, which is how an antenna radiates. We will study how an antenna radiates energy into space, and antennas, as you know, are the mainstay of wireless communications. We will not assume any background except a background with differential equations, differential integral, evaluating the integrals. I will introduce vector concepts as necessary as we go along the course. Okay. So, you do not have to know vector analysis beforehand. However, if you know vector analysis, some of these concepts might become very simple to you. However, if you do not have vector analysis background, this is a good area to learn vector analysis and vector calculus. Some of these topics will be further useful to you in various other branches of engineering. So, we will introduce vector calculus as and when required. We start from Coulomb's law, end at Maxwell's equations. That will be our first part of the course. In the second part of course, we take we take Maxwell's equations and then start applying it to different physical scenarios and discuss microwave engineering, we discuss transmission lines, radiation and optical fibers. The course is 40 hours. I will also give appropriate course materials. They will also introduce some numerical methods to the course. I will discuss how to obtain capacitance and inductance of practical structures using numerical methods. An important aspect of this particular course is that we will also introduce what is called as quasi-static analysis, which is a halfway between stationary and non-stationary electromagnetics, that is between time invariant or static and time varying electromagnetic fields. Knowledge of this will really help you in performing well in other courses as I have mentioned.